Hi, today we're going to talk about functions, and this should be a topic that you're familiar with, but there may be a few subtleties that were not clear in previous courses, so I want to make sure that I go through and highlight some of those. So first of all, there's a difference between a relation and a function. So a function is a particular kind of relation. So a relation is just a rule that relates elements from one set to elements from another set. A function is a relation, but it matches elements from one set, which we call the domain, to, and that's the important word here, unique elements of another set called the range. And that whole concept of a unique matching from domain to range. So basically what that means is that every element of your domain can only match with exactly one element in the range. You can't have something in the domain matching with more than one thing in the range. So we'll look at a lot of different examples to make sure that the idea is clear. So one way to represent a function is through a mapping. And we have a green set which represents the domain and a black set which represents the range. And you can see that, I have an arrow here, that each element of your domain, for example, A, that gets matched over to 1 in the range. And N gets matched over to 14 in the range. So everything in the domain is getting matched to only one element in the range. Another way of representing a function could be in a table. And once again, notice here that the first row represents your domain, and this is just another way of representing the mapping from the previous example. But all these elements are in the domain, and the ones in the bottom row are in the range. So it just tells you A is getting matched to 1, C with 3, F with 6, N with 14, T with 20. By the way, have you figured out what my rule is for matching these? So the important thing to tell if it's a function or not is look at what's in the domain. So A only shows up once in the domain, and it gets matched to a unique element, the number 1. So A is not showing up anywhere else getting matched to another number, and that's why it's a function. Another way we could represent it is with a set of ordered pairs. And remember, with set notation, we're using these braces on the outsides. And then every element of the set is separated by commas. So the elements in this set are actually ordered pairs. And once again, the first element in the ordered pair is from the domain, and the second one is from the range. Other forms, we could have an equation, or we could have a graph, and you're familiar with those. So here I have two different examples, and I want to determine if either of these represents y as a function of x. So if we look at the first one, we have x squared plus y equal 1. Well, if y is a function of x, that means we should be able to solve for y and then look at what we have. So in the first example, I could just simply subtract x squared from both sides. And I have y is equal to negative x squared plus 1. Now you're familiar from previous work that this is a parabola opening downward, shifted up 1. And you probably remember something about a vertical line test. And if you look at a graph and a vertical line, any vertical line drawn only hits the graph and at most one point, then your graph represents a function. So another way to think about it, instead of visually like that, is look at this and say, okay, if I pick a number for x and I plug it in, do I get one unique answer for y? So for example, if I pick x to be, let's say, negative 2. When I plug that in, I get the opposite of negative 2 squared plus 1, which gives me a negative 4 plus 1 is negative 3. I'm not going to get any other value for y when I plug in x equals negative 2. Now, that's just one example for x, and we have to make sure that there are no numbers for x that we plug in that would give us more than 1, but I think you can see that that's not going to happen. So this first equation does represent a function. All right, let's look at the second equation. If I try and solve this for y, I'm going to subtract x from both sides. And then I have y squared, so to undo that, I need to take the square root. So what's the square root of y squared? A lot of students will say y. And then I'm going to scream that, no, that's not the right answer. What is the right answer? The square root of y squared is actually the absolute value of y. Let me give you an example. What if I said, what's the square root of 7 squared? It's 7. But what's the square root of negative 7 squared? It's not negative 7. So it depends if y is positive or negative, or 0, as to what the square root is. So the square root of negative 7 squared is actually the absolute value of negative 7, which is 7. Because when you square negative 7, you get 49. So this symbol, the square root, represents the positive root, the positive square root, not positive and negative. So that's why we get one answer when we do the square root on our calculator, because that square root is a function, because it only represents the positive root. So going back to solving this problem, now we have that is equal to the square root of negative x plus 1. And instead of leaving it like that, we can write this as y equals plus or minus the square root of negative x plus 1. Now it should be pretty clear to see that if you plug in a value for x, y is going to be plus or minus the square root of that value plus 1. So we're getting two possible answers for y every time we plug in a value for x. And that makes it not a function, because I'm supposed to get just one value for y for any value I plug in for x. All right, let's look at some more examples. Which of these are functions? So here's a mapping. Is this a function? Well, what we need to look at is, are there any elements of my domain that are getting matched to more than one element in my range? And no. 1 is only getting matched to 4. 2 is only getting matched to 4. 3 is only getting matched to 5. Now, even though 1 and 2 are both matched to the same number, that's okay. It's just we can't have one getting having an arrow going from 1 to 2 separate numbers, or 2 or 3. So this is a function. It's a very simple function, but nonetheless it represents a function. Okay, here's another mapping. How about this one? Well, if you were just paying attention, you see that 5 is getting mapped to 2 different values. And so no, this is not a function. How about this table? Well, the first row represents the inputs, or the domain. So if I look, 1 shows up and it gets mapped to 2. Nowhere else is 1 being mapped to a different number. Likewise, negative 2 gets mapped to 5, and nowhere else is negative 2 getting mapped to something else. So we don't see any repetition in the first row, which represents our domain. So that means that each element in the domain is getting mapped to a unique element of the range. And it doesn't matter that positive 2 gets mapped to 5 and negative 2 gets mapped to 5. That's okay. By the way, do you know what the rule is for this mapping? You might have figured it out already. How about if we have a graph? Does this represent a function? Well, at first glance, you might think, oh, it kind of looks like a parabola. I know that passes the vertical line test, so yes, it's a function. Well, I guess I forgot to write this. So this one, yes, this is a function. But now looking at this graph, we do see a problem. And the problem, if I can get to it, lies with these 2 points right here. If you notice, both of these points have the same x value. So when x is 2, y is equal to 3, or it could be equal to 5. So x equals 2 is not getting mapped to a unique element of the range, and so therefore this is not a function. And once again, that vertical line test idea, I could draw a vertical line that would hit both points. How about this equation? Y equal 1 over x plus 2. So is that a function? So, well, think about what values you can plug in for x. You can plug in anything for x except 0, because you can't have 1 divided by 0. But any other real number for x works. And when you plug in a real number for x, do you get a specific y value, or do you get more than one y value? Well, obviously you're going to get one specific y value. So, yes, this is a function. All right, let's focus a little bit about domain. What's the domain for each of these functions? So we look at the first one, and the domain means what values can I plug in for x that won't cause a problem. When you see a fraction, you know you can't divide by 0. So plugging in a -2 for x would be bad, because I'd wind up getting 1 over 0, and I can't do that. Even though you can take the square root of 0, that's allowed, that equals 0. For this particular expression, that's not going to be any good, because it would be 1 divided by 0. So normally 0 is okay for a square root, but not in this case, because it's in the denominator of a fraction. So that tells me that I can't have 0, and obviously we can't take the square roots of negatives under the real number system. So the x plus 2, which is in the square root, that's going to have to be greater than 0 for this to be okay. And if I subtract 2 from both sides with my inequality, there's my answer. So the domain, usually we just put d with a colon, x is greater than 2. If you want to represent this with interval notation, what you're going to do is write -2 comma infinity, and then a parenthesis and a parenthesis. If we wanted to include the -2, we would use a square bracket like that. You never use a bracket around infinity because that's not representing a specific number. All right, how about another example? What's the domain for this function? Well, first you want to verify it's a function, and yes, all the inputs are different, so we don't have the same input going to 2 different outputs. And then, because there's only 4 specific values for this domain, I can't write this as an interval, or I can't write it as an inequality. It's actually 4 specific values. X is equal to 1 or 2 or -4 or 0. So what we usually do when you have specific values like this is we're going to write it as a set for the domain, and then you list those specific values. I'm going to put them in order, in increasing order. So -4, 0, 1, and 2. And there's your domain for that function. Okay, how about with this graph? Now it's getting a little more complicated. Now the way I like to think about finding the domain for a graph, there we go, is I'm going to draw a vertical line here. And this is my domain detector. And as I run this across the screen from left to right, it beeps whenever it hits the graph. Well, wherever it beeps, those are the x values that are in the domain. So as I'm running this across, it doesn't beep because that's an open circle, but then it starts beeping, beep, 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 and then it stops, and then it starts beeping again here, beep, 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 and then it'll stop, and then it beeps one more quick time, and then it doesn't beep anymore. So as you run this thing across, it beeps there, there, all of those values, doesn't beep there at x equals 0, doesn't beep. When we get to -1, it beeps, -2, -3, -3.1, -3.5, -3.9, -3.99, but then at -4 it stops beeping. All right, so now that you have the visual for that, let's go ahead and list those values. So I'll start writing it with an inequality. So the domain is going to be it's going to be, let's see, -4 less than x until I get to -1, but it could equal -1. And then from 0, it's not going to equal 0 because it's an open circle until we get to x equals 3. And there's a closed circle at 3, so x could actually equal 3. And then nothing between 3 and 4, but then finally at x equals 4. So that would be one way to write what the domain of this function is, using inequalities. If I was using interval notation, then I would write it this way. I'd say -4 with a parenthesis, and -1 with a bracket, because we're including the -1, union with, and then we're going to go 0 to 3. Don't include the 0, so use a parenthesis. We're including the 3 because it's a filled-in circle, so we use a bracket. And then union with, and now it's one specific value, so we're going to use those braces for set notation, and that would be the x value of 4. So either notation is fine, unless the problem specifically says use one or the other. But if you haven't used interval notation, I would start getting in the habit of trying that, because that'll come up more and more as we get closer to calculus topics.